All right, so checkpoint 18. The first question we have here says that two sisters at a restaurant each order ice cream. The flavors are strawberry, vanilla, or pistachio. Using the format sister 1, comma, sister 2, which organized list represents the sample space of the sisters' ice cream choices? So there's 3 different flavors, right? And there's 2 sisters. So if sister 1 wanted strawberry, right? Let's put an S for sister 1 because she wanted strawberry. What are the possible flavors that sister 2 could order? If sister 1 wanted strawberry, what other flavors could sister 2 want or order? Vanilla or pistachio. Could sister 2 also want strawberry? Yeah, right. This is the second sister could also get strawberry. So if sister 1's like, I only want strawberry, sister 2 could order strawberry, vanilla, or pistachio. Right, so those are 3 different options. Say sister 1 only wanted vanilla. If sister 1 only wanted vanilla, what options could sister 2 pick? Strawberry, vanilla, and pistachio. Perfect. Yep. So sister 2 could get strawberry, vanilla, or pistachio. So are you guys noticing a pattern with our different outcomes here for our 2 sisters? So that means that if the last sister is like, I only want pistachio, the answer choices or the other options that sister 2 could pick would be the same. Sister 2 could also get strawberry, vanilla, or pistachio. So we're looking for the list that has 9 options. And there's 3 S's, 3 V's, 3 P's all at the beginning. And then there should be different SVP on the end. I think there's only one that's like that. Yes. So let me know when you guys are ready to go on to the second problem. Dawson, are you okay too? Perfect. All right, so second one. This says that Jackson is planning a trip for his family. He determines the items, or he is taking the items shown in the table. What's the probability he will wear jeans and a red shirt? So I'll give you guys a second to find this, and then I'm gonna try and copy the table while you guys are finding it. I don't think I'm gonna do that. Take too long. Instead. Just write on this. Wait, are you also here? It's okay, you're fine. Okay. Alrighty. So this next problem says that Jackson is packing for a trip with his family, and he's taking the items shown in the table. So for pants, he can either wear jeans or khakis. He can either wear a blue shirt, a red shirt, and then he can either wear tennis shoes or sandals. So we want to know what is the probability that he will wear jeans and a red shirt. Okay, so jeans and a red shirt. What we want to do for this problem is we are going to determine the probability for each one of our columns. And since it has the word and in between them, we want to multiply our probabilities, okay, because it uses the word and. So for our first column here where we're talking about pants, how many total options does Jackson have to pick from for pants? Can either wear jeans or khakis. So how many total options does he have? 2, right? So he has 2 total options, but the question is saying he's going to wear jeans. So out of those 2 options, how many of them are jeans? 1, right? So he has a 1 out of 2, or a 1/2 chance of picking jeans. What's the probability of him picking a red shirt? So now we're looking at shirts. What's the probability of him picking a red shirt? 1/2. Perfect. And then for shoes, does it say that he has to wear tennis shoes or sandals, or can he wear either one? He can wear either shoe, right? Because it doesn't say. So there's 2 total options for shoes, but since he can wear both, we're going to put a 2 in the numerator as well, because he can wear both options. So now, since this probability uses the word and right here, right? And means we're going to multiply. So the next thing we're going to do is multiply all of these fractions together. Okay, remember that when you are multiplying with fractions, you're going to multiply straight across the top and then straight across the bottom. So 1 times 1 times 2 is just 2, right? And then 2 times 2 times 2. What would 2 times 2 times 2 be? Be careful. Remember that we're not adding, we're multiplying. So remember, 2 times 2 is 4. 4 times 2 is... So Naira, remember that we're multiplying, we're not adding here. So if I have 2 times 2, that's going to give me 4. So 2 times 2 is going to give me 4. And then I have to do 4 times 2. Yeah, so it's okay, because that's a mistake that I see all the time that students make, is you see 2, 2, 2, and you go, oh, 6. So it's okay. Just remember that we're multiplying. No, you're not. I make that mistake all the time, too. You're not the first one, I promise. So remember that we just want to make sure that we're multiplying. So that's where we get this 8 from. So now the last thing we have to do is simplify it, because our answers want us to write it as a reduced fraction. Okay, so if I have 2 over 8, if I divide top and bottom by 2, what does that simplify to? 1/4. Yep. So our answer for this problem with Jackson packing for his family would be 1/4. So he'd have a 1/4 chance of wearing jeans and a red shirt. Questions on that one? So the next question I have says a coin is flipped 3 times. We want to know what's the probability of getting exactly 1 head. So I'll give you guys a second to find this one. What's the probability of getting exactly 1 head? He should be back. He said his internet was having issues, so he'll be back in. So what's the probability of getting exactly 1 head? And let me know when you guys find this one. Okay, no problem. Is it okay if I start going over this question while you do that? She might be moving it already. It's all right. Okay. So this next question says that a coin is flipped 3 times, and the following list shows the possible outcomes. We want to know what is the probability of getting exactly one head. So in this problem, we are only looking for options where we get exactly one head, right? And that means that this first option, HHH, I will not be counting this because there's 3 and I only want exactly 1. So what are some possible outcomes that only have one head listed? HTT, perfect, that's 1. Wade says that there's 3 of them. Yep, there is 3. We can have tails, H, tails, and then the very last one is tails, tails, H. All 3 of these have exactly one head. Perfect. So I have 3 total options that only have exactly one head. And then how many different outcomes do I have listed here? What would be my denominator? 3 over 8. Perfect. Yep, because I have 8 total outcomes, or 8 possible, but only 3 match this problem. So my probability here would be 3 over 8. Yes, very nice. All right, next question has this table in it with pairs. And we want to know what is the probability of rolling 2 numbers with the sum that is less than 7. So it has this big table with ordered pairs in it, and it's asking what's the probability of rolling 2 numbers that are less than 7. Naira, have you also been able to find it? Perfect. Awesome. All right. So the question is saying, what's the probability of rolling 2 numbers with the sum that is less than 7? So what these ordered pairs represent is like this first one, 1 comma 1. That's saying the first time I rolled this dice, I rolled a 1. And the second time I rolled this dice, I got a 1. If I look at this one right here, 4 comma 4, the first time I rolled my dice, I got a 4. The second time I rolled my dice, I got a 4. Now, the question is saying a sum. So whenever you see the word sum, what math operation does that tell you is going on here? Addition, right? So we're going to be adding our 2 numbers together, and I want it to be less than 7. So what are the different numbers that when I add my 2 numbers together, what could my answer be for it to be included here? If it's less than 7, what could be my possible answers? 5 or 6, right? It could also be 4, 3, 2, or 1, like Dawson has, right? Because all of those numbers would be less than 7. Perfect. So let me do this because I think this will help. Just write on this table. Alrighty. So we need to go through and determine which one of these answer choices, when we add those two numbers together, would give us something that is less than 7. So if I look at the very first ordered pair, this 1 comma 1, if I add those two numbers together, 1 comma 1, would this give me something that is less than 7? 1 plus 1. Yes, right? 1 plus 1 would give me 2. That is less than 7, so that counts. What about the second one here, this 1 comma 2? Yes, wait, I do. Thank you. Yep, the second one would work. 1 comma 3, this gives me 4, right? This one works. 1 comma 4, if I add those two together, that's 5. This one works. 1 comma 5, this one gives me 6. That works because that is less than 7 still. What about this very last one here? This 1 comma 6, does that one work? Seeing some no's. Why does that one not work? Nair says 1 plus 6 is 7, right? So is 7 less than 7? No, right? 7 is equal to 7. So that's why this very last one will not work. Perfect. Okay. So now let's look at our second row. When we look at our second row, what is the last ordered pair that I can include for this problem? What's the last ordered pair I can include? I know I can include 2, 1 and 2, 2. Where would I stop? Remember, it has to be less than 7. Wait, if I have 2 plus 5, 2 plus 5 is 7, right? Is 7 less than 7? No, right? So what would be the last ordered pair that we could include here? The 2 comma 4, perfect. Because 2 comma 4, when I add those two together, that gives me 6, right? So that's the last one I can include. 2 comma 5 gives me 7, so that's why I don't want to include that one. All right, let's look at the row here with 3s. What would be the last ordered pair that I can pick in this one? I see 3 comma 3s. That is correct, because 3 plus 3 would give me 6, right? 6 is the highest number I can go to. What about this row right here with the 4s? With the 4s first. What would be the last ordered pair I can include with this row with the 4s? 4 comma 2, perfect. Yep, because 4 plus 2 gives me 6. Remember, 6 is the highest number I can go to. And then we have our next row with 5s. What would be the only one I could pick from this one, right? The only one I can pick is 5 comma 1, because anything after that is 7 or bigger. What about the very last row, the one with 6s? Can I include any of those? Nope, because the very first one I have is already 7, so that's too big. So now what we need to do is add up all of these options that we have circled. So I have 5 in the first row, 4, 3, 2, and 1. So when I add up all of those together, how many options do I have? $15, right? Perfect. So I have 15 options that when I add them together will give me something that's less than 7. How many total options do I have to pick from in this entire table? Remember, I have 6 in each row and I have 6 rows. So you can just do 6 times 6, which would give you 36. Perfect. Yep. So 15 out of 36 options give me numbers that are less than 7. Now the question wants us to enter our answer as a simplified fraction. So we have to divide top and bottom by 3. 15 divided by 3 would give me 5. And 36 divided by 3 would give me 12. So final answer here would be 5 out of 12. Perfect. Nice. Awesome. Good job, Natalie and Nara. All right, to next one. So for this problem, it's similar to the one we just did, except now instead of asking us for probability, we want to know how many outcomes have exactly one head. So I'll give you guys a second to find this one. So we want to know how many outcomes have exactly one head. Now for these problems, when you are asked for a probability, probability is where you put your answer as a fraction. If you're just asked for how many outcomes, that is just a number. Okay, so use the enter your answer as a number like this. Double check this last line to see if you're typing it in as just a number or as a fraction. Remember, fractions are only for probability. So we want to know how many outcomes have exactly one head. So if it has 2 or 3 heads in an outcome, I'm not picking it because it can only have one because the question says exactly one head. So when you look through these, how many of them have exactly one head? Remember, it can't have 2 because 2 is too many. It can only have 1. So I can have heads, tails, 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 head, tails, and then tails, tails, head. Do you guys see any other options that have only one head listed? Nope, I don't either. Now, the question is asking us how many outcomes. So it's not asking me for probability. Nowhere in this question does the word probability ever come up. So the number of outcomes that have only one head are just these 3 choices. So that's all you're typing in here is just 3. You're not putting it as a fraction because it's not asking you for probability. So only type it as a fraction if it's asking for probability. No, Dawson, so the one we did before this was asking about probability. That was this one. See how this one uses the word probability in it? So that would be the one where we do 3 over 8. This one is just asking for the number of outcomes, which would just be 3. So they're the same exact question, but the only difference is those 2 words. One's asking for probability, and then one is asking for outcomes. So we did one almost identical except for that one word. So double check on your checkpoint that for the one that has outcomes, you're only typing 3. And then the one that has probability, that's the one where you do 3 over 8. Perfect. Okay. Yeah, and technically, if the checkpoints didn't shuffle your questions, this one would have come first because you'd want to know how many outcomes and then do the probability. But since it shuffles, we did them backwards. No, you're not going crazy. It's okay. Alrighty, next problem. So here we have a long one, and we want to know what's the probability of randomly building a pizza with red sauce and pepperoni. So red sauce and pepperoni. So there's also one very similar to this that's like red sauce and sausage. Make sure that you double check it and it's asking for red sauce and pepperoni. Yeah, there's a lot of very similar ones. So just double check it. Make sure it says red sauce and pepperoni. So Naira, that one's probably a different one. So there's a lot of problems on this checkpoint that use the same setup, just with different questions. So click through the other ones to make sure you find one that says red sauce and pepperoni. Found it? Perfect. Okay. Are we all good? Alrighty. So here, for this problem, because it uses the word and in between them, right, that means that my pizza has to have red sauce and pepperoni. It must have both because of the word and in between them. So if I look at what these letters represent, the very first one represents the type of crust. So that could either be stuffed crust with an S, thin crust with a T, and that's it. So I only have two options for my crust, stuffed or thin. The middle letter represents the type of sauce. So that's either red sauce for R or white sauce for W. And then the very last letter represents my topping. So that can either be P for pepperoni, S for sausage, or V for vegetables. Okay, so I'm looking for red sauce and pepperoni, which means my first letter can really be whatever. It doesn't matter what my first letter is. I can either have a stuffed crust or a thin crust because the only thing I'm looking for is to have red sauce in the middle for an R and then a P at the end for pepperoni. Okay, so I need to have red sauce in the middle, so R in the middle, and P on the end for pepperoni. So if I look, this very first option says R and P in the same exact order. So this is one that I want to include. And then none of these have R and P for the last two. This one does though, right? R and P. And if I keep going, that's it. So I only see two options here that have R and P. Do you guys agree? Perfect. So I have two options that where I can choose red sauce and pepperoni. How many total options did I have to choose from here? So how many different outcomes could I have chosen? 12, right? There's 12 different options. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 total. So I have 2 over 12. And I can simplify this, right? Because it wants me to write it as a reduced fraction. So this would equal 1 over 6. Perfect. Yep. So my probability here would be 1 over 6. All right. Our next one has that same table with the numbers, but this time it's asking us what is the probability of rolling two even numbers. So same table, but now we want to know what's the probability of rolling two even numbers. All right, Wade's there. We know when everyone else is as well. All right. Let's see. Natalie's ready. What about Dawson? Think? All right. Does it make sure it's asking what is the probability of rolling two even numbers? That's the question. Nope, never mind. Yeah, this checkpoint, they have a lot of questions that use the same exact setup, but just different questions. So it makes it slightly harder when you're clicking through trying to make sure you find the right one. So it's okay, take your time. All right, perfect. So what is the probability of rolling two even numbers? Okay, so first of all, if I have a dice, what are the even numbers that I could roll from a dice? Well, those 1 through 6 are all the numbers. Right here, I only want to roll even numbers. So what would be the even numbers I could roll? 2, 4, 6. Perfect. Yep. So on a dice, I could roll a 2, a 4, or a 6. So since I only want to roll even numbers here, Wade says it's 18 because if I multiply 6 by 6, you get 36. So 36 is your total options. That's good. And then when you divide that by 2, you get 18. So Wade, hold on to your thought process because I like where you're going, but let's look at this first. So I can only roll two even numbers, right? If I look at this first row here with ones, one is odd, right? So I can't roll a 1. That doesn't count. So all these options in that first row are automatically out. I can't pick any of those because they're not both even. If I look at the second row here with 2s, 2 is even, but the first one, 2, 1, this 1 here makes it not work because 1 is odd. But 2, 2, these are both even, so that counts. 2, 4, these are both even, so that counts. And 2, 6, these are both even, so that one counts. In the third row, the one that starts with 3s, can I pick any of those? Would any of those work here? Wade, do you think any of those options would work here? No, right? Because 3 is odd and both of them need to be even, so I can't pick any of those. How many options in this fourth row do I have that work? The one that starts with 4. How many options do I have in this one that work? 3, right? Perfect. I have again 4, 2, 4, 4, and 4, 6. And this fifth row where all of them start with 5, I can't pick any of those, right? Because they all start with 5, so that doesn't count. But in this very bottom one, the ones that start with 6, how many possible ones can I pick in that very bottom row that would work? 3 again. Perfect. All right. So I have 3 in my row with 2, 3 in row with 4, and 3 in row with 6. So how many circles, sorry, how many total ones did I circle here? My total outcomes. There's 9, right? So I would have 9 out of 36 because like Wade said, I have 36 total options. And Wade, the reason why dividing it by 2 doesn't work here is because I'm rolling 2 dice. If I was only rolling 1 dice, then what you said it would work. But since I'm rolling 2 here and both of them have to be even, that's why it's 9 and not 18. No, that's okay. You're fine because your thought process was good. Like where you started was good. It's since we're rolling 2 dice, you just have to keep that in mind. So for these problems, I always use the table and I just go through and circle or like I mentally count which ones work and then I put that over the total. So I think that's the easiest way to go about these is just, well, if I have this table here and I can only roll 2 evens, well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 different options, right, out of 36. So with probability, your denominator will always be bigger than your numerator. You don't want to flip it around because if you flip your fraction, it's not the same, right? 9 over 36 is not equal to 36 over 9, right? Because 36 over 9, this is 4, and 9 over 36 is 1/4. So since they're not the same number, don't flip it. So your bottom or your denominator should always be bigger than your numerator when you're writing probability problems. Okay. And then since we want to reduce our fraction, our final answer for this problem would be 1/4. So 1/4. So Wade, does it make more sense going through it this way? Okay. Natalie, that's fine. Sometimes when you don't reduce it, it counts it as right, but sometimes if you don't reduce it, it marks it wrong, even if it's the same. So just get in the habit of simplifying it just in case, because there's some questions like on your exam where if it's not simplified, it'll mark it wrong. So if you take your exam and you think that you got your answer right, but you just didn't simplify it, send me an email and then I can go in and give you points because I can't edit answer choices or correct answers on the exam. All right, next one. So next question I have is saying that Allison wants to buy a new tablet and she goes to the store and can choose between red, white, and black ones. All right, so Wade's there. Let me know when everyone else is. Natalie's there. So is Naira. No problem, Dawson. It's fine. Let's back up because I'm probably going to use this one. Perfect. All right, so Allison's buying this new tablet and she goes into the store and she can choose between a red, white, and black one. And then she can also pick a 36, 64, or 128 gigabytes of memory. So if Allison goes into the store and she goes, I really want a red tablet, what are the different sizes that she could get in that red tablet for storage? She has 3 different options, right? She could get a red tablet that has 36 gigabytes. She could get a red tablet that has 64, or a red tablet that has 128. Perfect. Now, what if she is like, I'm not really feeling red. I want white. How many different options does she have for storage when she chooses white? 3, right? The same 3. She can choose 36, 64, or 128, all with white. And then say she's like, I had a white and red one last time I chose one, so I want black this time. It's the same thing. She can pick 36, 64, or 128 gigabytes. So regardless of what color she chooses, she'll have the same 3 storage options. So we want to pick the answer choice that has the 9 options. So 3 red, 3 white, and 3 black. So on this one, it would be the longest example, or I guess the longest answer choice that has 9. All right. Next one is talking about Jerica. And it says that Jerica is picking a new coat for the winter. And she can pick blue or purple with button, zipper, and both. Oh, sorry, Wade. All right. So next one, again, is talking about Jerica, about her picking a new coat for the winter. All right. And then, Wade, are you good for this one? Perfect. Okay. So the question here is asking us, it says based off the table, what is the probability that she chooses a coat with a zipper? So in this problem, I just want to know, out of all these total coat options she has, this purple with buttons, blue with buttons, purple with a zipper, blue with the zipper, purple with both, blue with both, out of all those, how many of them have a zipper? So obviously these two right here, right, purple with zipper and blue with zipper, both of those say zipper, so obviously those work. If she has a jacket with both means that it has a button and a zipper. So it's like double closures, right? She has buttons and zippers on this last one. So if this very last one, the category with both, has a button and a zipper on it, do those count for also being a coat with a zipper? Yeah, perfect, right? Wade got it. So for this example, these two options also work because since it has both, it has a zipper included in it. So that means that she has 4 total options that include a zipper, and she had 6 to choose from, right? Because we have 1, 2, 3, 4, 5, 6 options here. So 4 out of 6 have a zipper. And then we can simplify that to 2 over 3, like Natalie said. Perfect. Good catch, Wade. So for these ones, make sure that you're taking your time to read these carefully. And think about what both means. If you're like, what is both? Think about what the problem is talking about. All right. So next one is the multiple choice question that has all the tables talking about ice cream. Right, Wade's there. There is there. Okay, no problem, Natalie. So you can go ahead and submit it, and then you're free to go to work on other stuff. And I don't know if you guys noticed, so since state testing was canceled, the pacing for these next 2 weeks is going to be incredibly slow. I only had one assignment due each day because of the testing, and I didn't know like which week you'd be testing and things like that. So we have pretty much 2 weeks to finish this probability unit. So don't feel like you have to do everything in one day. If you finish all of like lesson 19, pretty much is due this entire week. Like week. You have this entire week to do this one lesson. So take your time with it, or get it done all in one day if you want, and then use the time to go into other classes and get caught up or redo assignments. Yes, Dawson, what is your question? Natalie, you can stay until we're done with this checkpoint unless someone else has other questions. All right, Dawson, will you type your question? I'm going to start going over this problem. We have an ice cream shop that has chocolate, vanilla, and strawberry flavors. And for toppings, you can put hot fudge, caramel, sprinkles, and walnuts. And we want to know which one of these outcomes, which one of these tables represents the outcomes for a one topping sundae. So for ice cream flavors, I have 3 flavors I can pick from, right? I can pick from chocolate, vanilla, and strawberry. How many different toppings do I have in this problem? How many different toppings do I have to pick from? There's 4, right? I can pick hot fudge, caramel, sprinkles, or walnuts. So since there are 4 toppings and 3 ice cream flavors, right? Chocolate, vanilla, or strawberry, I want to pick a table that has 3 ice cream flavors as well as 4 different toppings. So each flavor and each topping should have a different column. Now, there's 2 tables that look very similar, but be careful. If I look here at this table, this says chocolate with vanilla and then chocolate with strawberry, but vanilla is not a topping, right? So this very bottom table here wouldn't work. So read through your tables and make sure that you're choosing the answer choice where all of you should have 12 total options, and they all have a ice cream flavor and a topping with it. So this is the one that you want to look for. And then Dawson, the Jericho one was 2 out of 3, so 2 over 3. So I'll give you guys a second to make sure that you're choosing the right one. And then let me know when you're ready to go on to the next one. All right, Dawson's good. Naira and Wade, let me know when you guys are ready. Perfect. All right, next question has David tossing a coin, and we have this table, and it says first coin, second coin on it. All right, Dawson's good. Wade is there. All right, perfect. So David is tossing these 2 coins, and these are all the different outcomes that we could have. We could either have heads, 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 tails, tails, head, or tail, tails. We want to know what is the probability of both coins landing on heads. So knowing what we've been doing to solve problems like this in this checkpoint, what do you guys think is the probability of both coins landing on heads? Yeah, Dawson, you can go ahead and ask your question now. That's fine. All right. So I have this one option where both of them are landing on heads, right? So that's one option. And I have 4 total outcomes in this table. So I would have 1 over 4. So the probability of both coins landing on heads here would be 1 over 4. So 1 over 4. We good to go to the next one? All right. Our next problem has all of these different tables, and it says an experiment involves rolling a dice and flipping a coin. So I will give you guys a second to find this one. All right, are we good for this one? Ready? Okay, no problem there. We're almost done. We have like, I think 4 more, including this one. All right, for this problem, if you look at your answer choices, it a lot of the tables that we have here for these 3 answer choices, they kind of look the same. They have the same amount of options, and they're all kind of set up the same way. However, we have to be careful with what the ordered pairs actually are. So notice how the first column that we have in each of these is heads, right? Which means that in that entire column, we should have heads. In the second column, we have entirely tails, right? Which means that in our second column, we should have nothing but tails. So if I look at this first table, this first column here has 1, 1, 2, 2, 3, 3, 4, 4. Well, this one can't work because I should have heads in this second column, and there's no heads there. So this one is out. If I look at the second table, I have 1 heads. Heads are all down this one, and tails are all down this column. So that one looks good. Let's double check this very last one. In this tails column, I have some heads here. Those heads shouldn't be here because they're already here, right? In this column, I should only have tails. So I want make sure that you're just picking the table that looks correct, right? So you have a number and then heads all in one column, and then a number and tails all in the next column. All right, so Wade is good. Dawson and Naira, let me know when you guys are ready. All right. Next one. So it says that a social studies test has 4 true or false questions, and the following shows all the different possible outcomes that students could pick. And we want to know how many outcomes include 2 true and 2 false answers. So notice here that this question is asking for 2 true and 2 false, but it's also just asking us for outcomes. It's not asking us for probability. So that means our answer for this question is going to be just a number. It's not going to be a fraction because it's only asking us for outcomes. See, Wade sees 5. All right, let's see. So here's 1. 2 true, 2 false. Another one, 2 true, 2 false. Here's another one. Another one. And another one. Another one. I think that's it. So I count 6. Did you maybe miss one? It's okay. You're fine. It's a lot to look at. I definitely agree. It is a lot to look at. So I have 6 different options where I could have either 2 true or 2 false, right? So there's 6 out of how many? How many different orders could I answer those 4 questions based off of this big list here? You're good at hidden object games? Yeah, like Where's Waldo and stuff like that. But even for me on these questions, I actually just go back and double check. Also, ignore my last question because it doesn't matter how many total options there are because here we're just looking for outcomes, right? So since we know that there's 6 different outcomes, the answer for this problem would just be 6. Because there's 6 ways where a student could pick 2 true and 2 false. So 6 is our final answer. All right, 2 more. Number 14 for me. All right, so this one is talking about Cami, and it says that Cami wants to buy some new shoes, and it has a multiple choice question with different colors and styles of shoes. All right. So Cami is going to buy some new shoes, and she goes to the store, and the shoes that she wants can either be black, white, or red. And she can also choose shoes whether they're flat, have a small heel, or have high heels. We want to know which list correctly displays all of the choices that Cami has for her new shoes. Okay, well, I mean, if she wants to have black shoes, she could either have a black shoe that is flat, has a small heel, or has a high heel. If she wants white, she can either have a white shoe that is flat, has a small heel, or a high heel, right? Or she can have a red shoe that is flat, has a small heel, or is high heeled, right? So this is just kind of like what we've been doing with these questions before. So out of these answer choices that we have, which one do you guys think is correct? It says the bottom one. I agree. Because these are all the different answer choices that we just went through. She could pick a black shoe, and she has 3 different options for the type of shoe that she's going to get. So I agree with Wade. This bottom one is correct. The longest one. Yep, exactly. All righty. And then very last one. So this is the one that has red sauce or sausage. So this is that other question, but instead of the and pepperoni, it's or sausage. So red sauce or sausage. So let me know when you are here. Make sure it's red sauce or sausage. All right, Dustin, are you almost there? It's okay, you're fine. Alrighty, so for this one, it's the same exact scenario as before, where the first S or T stands for thin crust or stuffed crust. The middle is either red sauce or white sauce, and then the very end is talking about pepperoni, sausage, or vegetables. Okay, so here this question wants to know how many outcomes include having red sauce or having sausage. So I am going to count any options that either have an R in the middle or have an S in the end. Okay, since it's not and, it doesn't have to have both. Since it says or, it could either have red sauce or it could have sausage. It doesn't have to have both for this one. So again, I'm looking for an R in the middle or an S at the end. Okay, so it could be either of those. And it can have both in one, that's fine. It just needs to have at least one. So this first one, SRP, that one has an R in the middle, so that one counts. SRS, that one has an S on the end, that one counts. This one here, SRV, this one also has an R in the middle, so that counts. I have SWS, it has an S on the end, that counts. I have TRP, R in the middle, another R in the middle, R in the middle, and S at the end. Okay, so these are all of the options that either have red sauce, right? These ones have red sauce. And then these two don't have red sauce, but they have sausage, so those count. Okay, do you guys see why I circled the ones that I circled here? Yeah. So again, we're including any of the ones that have red sauce or if they have sausage. So they could have only one of each if they wanted to. So it's just asking for outcomes. So all we have to do is just add them up together. So I'd have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 possible outcomes that include red sauce or sausage. In Dawson, it doesn't have to be out of 12. It's just 8 because remember, it's only asking for outcomes. If it was asking for probability, that's when you would enter it as a fraction. And again, use this to help you remember. See how it says here to, why is it highlighting all of it? Sorry. It says enter your answer as a number, like this, 42. So that's a hint for you to be like, oh, I only need to type in 8.